Hi everyone, Miss Tui here. When you think of a wave, what do you imagine? Maybe you picture someone waving hello or goodbye. Maybe you think about fans at a sporting event. You might picture a lake or the ocean. If you thought of any of those, you know exactly what a wave is. Or do you? For today's lesson, you will need an Ozobot, fully charged and calibrated, a pencil, color code markers, your patterns and waves activity sheets. Make sure to have both pages and a color code chart. After today's lesson, you will be able to recognize wave patterns and define key wave vocabulary. A couple things about waves to remember. Waves are regular patterns of motion, and waves transmit energy. Today, you'll get acquainted with waves and the vocabulary associated with waves. First, you'll find the rest position. No, it isn't nap time. I mean the rest position of a wave. Look at wave 1 on your activity sheet. There is a dotted line through the wave pattern with an arrow and a place to label. This dotted horizontal line represents the rest position, also known as the resting point. An example of this would be the ocean on a very calm day with no waves. The water is flat. This flat ocean with no waves represents the rest position. Can you write rest position on the blank to label the rest position of wave 1? Next, find the highest point on the wave line. This point is called the crest. Note there are 2 crests in wave 1. Find the lowest point on the wave line. This point is called the trough. There are also 2 troughs in wave 1. Notice the spelling of the word trough. It's spelled like the word enough. The O-U-H ends with the F sound. Again, the lowest point on the wave is called the trough. On wave 1, can you label the crests on the highest points of the wave and the trough on the lowest points of the wave? If you like to listen to music really loudly, you might know that musicians use amplifiers to turn up the volume on the instruments they play. With waves, the distance from the rest position to the crest of the wave is called the amplitude. You can also measure the amplitude from the rest position to the trough. In sound waves, the greater the amplitude, the louder the sound. In ocean waves, the greater the amplitude, the better the surfing. On wave 1, can you label the amplitude? Do you prefer the sound of a flute or a bass drum? A flute makes a higher pitched whistling sound, while a bass drum makes a lower pitched rumbling sound. What does that have to do with waves, you ask? Quite a lot, in fact. The distance from one crest to the next crest on a wave is called wavelength. Wavelength can also be measured from one trough to the next trough, or from any point on a wave to the corresponding point on the next wave pattern. On wave 1 of your activity sheet, it is the distance from the rest position on the left to the rest position on the center of the page. Notice that the wavelength measurement starts at the rest position, passes through the crest, the rest position, a trough, and ends back at the rest position. So the wave is going through a complete cycle. That complete cycle is called a wavelength. Returning to the flute and bass drum. A flute produces a shorter wavelength sound, creating a higher pitch. A bass drum produces a longer wavelength, creating a lower pitched sound. On wave 1, can you label the wavelength? Our last vocabulary word is frequency. Frequency is the number of wavelengths or cycles in a given amount of time, usually in seconds. We can call this measurement cycles per second, but more often the measurement is called hertz, abbreviated Hz. If wave 1 took place in 1 second, we would say the frequency of wave 1 is 2 hertz because it contains 2 complete wavelengths in 1 second. Can you write the definition of frequency below the word bank on page 2 of your activity sheet? Can you also fill in the blank for the statement, frequency is measured in blank? On the bottom of page 1 on your activity sheet, there are 4 more places for wave patterns. You will use wave 2 as a guide to make waves 3, 4, and 5. Observe wave 2. Notice the amplitude and the wavelength. In the box for wave 3, draw your own wave, similar to wave 2, that has a smaller amplitude. Keep the wavelength the same, only change the amplitude. If this was the sound wave of a guitar, how would the sound change? For waves 4 and 5, you'll also draw a wave similar to wave 2. Wave 4 will have a smaller wavelength, and wave 5 will have a greater frequency. How will those changes affect the output of a sound wave? For wave 3, can you draw a wave similar to wave 2 that has a smaller amplitude? At the bottom of the box, write how the sound would change if it had a smaller amplitude. For wave 4, can you draw a wave similar to wave 2 that has a smaller wavelength? And for wave 5, can you draw a wave similar to wave 2 that has a greater frequency? Write how those changes would affect the sound of a sound wave. On the bottom of page 2, you'll notice a free draw space. Use this section to draw your own wave pattern for your Ozobot to travel on. Start by using a pencil to plan your wave pattern and color codes. Can you make it a loop so that your bot travels on it over and over? What color codes would you use to represent the differences in the wave patterns you draw? Choose 4 to 5 color codes and integrate them into your wave pattern. When you are satisfied with your plan, fill in the color codes and black lines. Place your Ozobot on the line and observe how your bot travels and responds to the color codes. Can you use the free draw space and 4 to 5 color codes to make a wave pattern loop for your Ozobot to travel on? Well done. Answer the following questions to be sure you've completed this activity. Did you label wave 1 with all 5 vocabulary words? Did you write the definition of frequency and the term used to label measurements of frequency? Did you fill in waves 3 to 5? Did you create your own wave pattern using 4 to 5 color codes? If you'd like more to do, label the parts of the waves in waves 3 to 5. Find the answers to the question, if you played a drum on the moon, would you hear it? Discover other things that are transmitted through waves. Or build a wave machine using tape and straws to discover more about amplitude, wavelength, and frequency. Come back again soon for our next lesson.